Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering. So in today's class, we are going to discuss the numerical problems on the dot convention. In the previous class, we have discussed the basic problems. So we have discussed already 2 problems in the previous class. So in this class, we are going to cover 2 more problems, right? So to get better understanding or to get a better application of this dot convention, so we are going to discuss 2 more problems in today's class. Right. So first, let me go with the problem number 3. So let me read the problem here. A mutual inductor is used to couple a 20 resistive load to a 506 at an angle of 0 degrees voltage generator as shown in the figure. So here one more point let me discuss before going to the problem in details. So as you can see, actually when we are discussing about the mutual induction principle, we didn't cover about what are the practical applications of the mutual induction principle, right? So as you can see here, this mutual induction principle, okay, so as you can see here, what is this circuit indicates? Okay, it is a generator. So which means in machines we can use this mutual induction principle, right? And also in the transformers, also we will use the mutual induction principle, right? So yeah, then coming to the problem, yes, and the generator has an internal resistance of 5 ohms and the mutual inductor parameters are R1 is equal to 20 ohms and L1 is equal to 0.2 henries with respect to the primary winding. And with respect to the secondary winding, here R2 is equal to 25 ohms and L2 is equal to 0.4 henries. And the mutual inductance between the 2 coils, here it is 0.1 henries. And the supply frequency is 75 Hz. Then determine the first problem here it is the generator current I1 and the load current I2. Of course, here this problem is almost similar to the problem 1 that we have already discussed. Okay. So of course, here only the change here it is, here they have given in the frequency domain. So we need to consider the frequency also here. So which means instead of L, we have to write XL, which is equal to 2 pi F into L. Then the same procedure that we are going to apply in this case also, the same procedure that we are going to follow, whatever the procedure that we are followed in the previous problems. So here first what we need to do, first we need to write the voltage equation with respect to the primary winding or with respect to the circuit 1. So which means here the voltage E1 is equal to 50 at an angle of 0. So which means here, let me start with this 50 at an angle of 0 degrees. Yeah. And before that, so we should know what is the sign of the mutual inductor, the mutual inductance here. Of course, here as you can see here, these are the 2 dots placed for the primary side and the secondary side. And here the current direction is like this, which means here with respect to the primary winding, the current is entering through the dotted terminal. And in the secondary terminal, the current direction is like this. Okay. So which means here the current is leaving through the dotted terminal. So which means here one is entering, another one is leaving. So the mutual inductor will have the negative sign, right? So then 50 at an angle of 0, which is equal to, first of all, we have to write the voltage with respect to the, what is that, the self inductance. So which means here, what are the other parameters here? R plus R1 plus J omega L1 into I1 minus, of course, anyway, here this is also imaginary term. So J omega M into I2. This is the equation which is related to the primary winding. Let me just substitute the values also. So here R value, here it is 5 ohms and R1 is 20 and here J is equal to 2 pi here F, F is equal to 75 Hz only. So 75 into here L1 is equal to 0.2 into I1 minus J into 2 pi into F is equal to again 75 into what is the mutual inductance value? Here it is 0.1. Right. So if you simplify this, then you will get finally the equation for the primary voltage equation. Here it is I1 into 25 plus J30 minus J15 into I2, which is equal to, again the voltage here it is 50 at an angle of 0 degrees. Let us consider this is equation number 1. Then similarly, for the secondary terminal, let me write, okay, anyway here it is equal to 0, which is equal to 0. And what are the resistors here? R2 plus RL, and plus J omega L2, J omega L2 into I2 minus J omega M into I1, right? Then substitute the values here. The value of R2 here it is 25 plus, and RL here it is 20, and J into 2 pi into here F is equal to 75, I think so. 75. Sorry, here it is not only 75, here some printing mistake is there. Here 75 by pi here actually. Okay. So then here also it is 75 by pi. Some printing, some typo mistake is there. So here it is the frequency F is equal to 75 by pi Hs, right? Then here also it is 75 by pi into L2 value here it is 0.4 into I2 minus, again the same way, J into 2 into pi into 75 by pi into M is equal to 0.1 into, again here it is I1. So if you further simplify, then you will get the equation here, which is equal to, let me write here, of course, anyway, this is 0. So minus J15 into I1 plus 45 plus J60 into I2, which is equal to 0. So this is equation number 2. The same way, so by solving equation number 1 and 2, then we can find the values of I1 and I2. So let me write here, because I have already calculated the values of I1 and I2 by using the calculator. So here I1 value, which is equal to 1.30 at an angle of minus 45.84 degrees, and I2 value, which is equal to 0.26 at an angle of minus 8.97 degrees amperes. So these are the values of I1 and I2 values. Actually, what they are asked us to find, first one is determine the generator current I1, of course, I1 that we have calculated, and the second one, of course, the I2. Yeah, both we have calculated, I1 and I2. So this is how we can find the value. And another thing here, suppose the same way, if the current in this case is this direction instead of this, then what it could be the equations? The same, just the plus. Okay, so which means here V1 is equal to let us consider here L into, the self inductance, total inductance. Okay, L into I1 plus M into I2, and similarly V2 is equal to here what is that, L1, right? Okay, so L2 into I2 plus M into I1. So here you will get the plus sign. Okay, because in the primary winding the current is entering through the dotted terminal, in the secondary winding also the current is entering through the dotted terminal. So that's why here the mutual inductor will get the positive sign. Next, the fourth problem. Of course, this is a little bit complicated when compared to the previous 3 problems. Of course, not that much complicated, but here a little. Okay, because as you can see here, you will be having one inductor is common for both the circuit, this L. Okay, but here L1 is related to the primary side and L2 is related to the secondary side, but here L is common between the 2 circuits. So that is the only difference between the previous problems and this problem. Of course, anyway, this is also not that much difficult. Okay, so let me explain in a simple way. So actually, first let me read the problem. The mutual inductor of the problem 3 is connected to the circuit of below figure. Of course, yeah. So here we have to consider some parameters from the problem 3 also, and determine the source and the load currents. Okay, for a windings as shown that is with the dots adjacent, and with one winding reverse, that is with the dots at opposite ends. Yeah. So which means here we have to find, again in this case also we have to find I1 and I2 values, but the only difference here it is in the first case we have to find the I1 and I2 as it is the what is it, because here they didn't mean, as the directions mentioned in this particular figure. And in the second case we have to reverse any one of the winding, okay, and again find the values of I1 and I2 values, right? Yeah. So first let us go with the directions of the currents as it is, that is given in the particular circuit. So here again let us apply this dot convention principle. Of course here the circuit direction is like this, the current direction, which means with respect to the primary winding, here the current is entering through the dotted terminal, but here again with respect to the secondary winding, okay, the current is leaving from the dotted terminal. So that's why here as usually the mutual induction having the negative sign with respect to the self inductor, right? The mutual inductor having the negative sign with respect to the self inductor. So here also the same way, just first let me write the voltage equation with respect to the circuit 1. So for the circuit 1, first let me write here, okay, the voltage is E1, here it is E1, which is equal to what are the other resistors and inductors that they are having here, which is R plus R1 plus, of course anyway here it is J omega L1 plus and J omega L. Yeah, one more R is also there. Small r, capital R1, and one more R plus J omega L1 plus J omega L2 into, because these all parameters are with respect to the self inductance, okay, so which means I1, and minus here in between these two there are two resistors, what is that, the two inductors are there, so that we need to take care. So one is M into minus M into omega, no sorry, J omega M. So J omega M into I2, so that is due to the mutual inductance. And another one here it is because in this circuit also the current I2 will flow, right? So that's why then here minus here I2 into R plus J omega L. This is the only difference between the previous problems and this problem. Okay, so just listen carefully. This one is fine. Okay, same like as in the previous. Okay, with respect to the primary circuit, and this one is also with respect to the current flowing through the secondary current. Okay, because of the mutual inductance, we will get some voltage. And another one because of this particular, okay, because in this case in this circuit also some current I2 will flow. So because of the current I2 will flow in this particular coil, okay, again some amount of the voltage will induce. Okay, so that's why this also we should write I2 into R plus J omega L, right? So then substitute all these values here. Here E1 is equal to 50 at an angle of 0 degrees, which is equal to R is equal to 5, and R1 here it is 20, and again R is 8 plus J as usually 2 pi into, of course, F here it is 75 by pi into L1 0. I think, yeah, 0.2 0.2 plus J into 2 pi into, again F is 75 by pi into, again L2, not L2 actually, exactly here this is L only, because this one is L. So here it is 0.1, right, into I1. As usually here it is J into 2 pi into again F is 75 by pi into I2. Where is I2? Here it is. Yeah, I2 as usually, and minus I2 into here R is 8 plus J into 2 into pi into 75 by pi into L is 0.1. The lengthy equation, right? Okay, anyway, if you just simplify this, then we will get finally the equation. Here it is, I mean, in terms of I1 coefficient and I2 coefficient. So let me write, because I have already simplified this one. So let me write here. This is J 2 pi. Okay, then the final value I'm writing here. Okay, instead of, because the simplification you know very well. So here it is 33 plus J 45 I1 minus 8 plus J30 I2. This is equation number 1. Of course, before the voltage here it is 50 at an angle of 0 degrees. Right. Similarly, write equation number 2. Okay. So the equation number 2 again, just I am writing equation number 2. Here it is 0. Okay. And first, let us write all the parameters. So here it is. Start with R plus R2 plus RL plus J omega L2 plus J omega L into I2 minus M into J omega M into J omega M into here it is L2. J omega M into I1 and minus here again I2 into which is L plus R plus J omega L. R plus J omega L. Right. So just substitute all these values here. You know what is R value, R2 value, and RL value. So here R value here it is 8 plus here R2 25 plus here RL 20 plus. So here it is again J2 pi into F is 75 by pi into here L2 value is 0.4 plus J into 2 pi into 75 by pi into again what is here it is L. So L value here it is 0.1 into I1 and minus as usually J2 pi F into what is M value here it is 0.1 into I1 minus again I2 into R value here it is 8 plus again J into 2 pi F into L value 0.1. Okay, then again simplify as usually like in the first equation. Then here let me write the final equation. So after simplifying this, then the final equation will become here minus 8 plus J30 into I1 plus 53 plus J75 I2 which is equal to 0. This is equation number 2. So here as you can see, the applying the concept is very important. Once you apply the concept, then while doing these calculations also you should take care. Okay, because here if you miss any one value, or if you miss instead of plus if you substitute minus, or instead of minus if you substitute plus, then totally you will get the currents I1 I2 will get wrong. Okay, so that's why you should take care while doing these calculations. Then the same way like in the previous cases, okay, by solving 1 and 2, then you will get the values of I1 and I2. Anyway, I have already solved these equations by using the calculator. So let me write the values of I1 and I2. So I1 here it is 1.03 at an angle of minus 45.47 degrees amperes. And similarly, I2 is equal to 0.35 at an angle of minus 25.15 amperes. So these are the values of I1 and I2. When this is the first case, so which means the directions of the current as usually that they have given in the problem. But in the second case, what we have to do, just change any one of the direction. Okay, so which means in this case, okay, so instead of this, let me take the direction is like this. Okay, so which means In the primary winding, the current is entering through the dotted terminal. In the secondary winding also, the current is entering through the dotted terminal. So, which means here both the inductor and which means the self-inductance and the mutual inductance having the same sign, which is positive. Right? Of course, the values will not be changed, only here where, so here and here you will get the positive sign in the first equation, and the second equation here also you will get the positive sign. That is the only difference. Then let me directly write the equations here, okay, because you can write the equations as usually same like in the let me write here, okay, the standard equations. So V1, which is equal to L1, not L1, okay, simply I am writing L into I1 plus M into I2, and V2 is equal to here L into I2 plus M into I1. Right? So just you apply this concept to this particular circuit, then finally you will get the equations. Okay, for your reference purpose, I am just writing because I have already done. These equations are, the first equation here it is 50 at an angle of 0 degrees, which is equal to I1 into 33 plus J45 minus I2 into 8, which is equal to, already we have written. Okay, this is equation number 1. And similarly, the equation number 2, after simplifying the equation number 2 that you will get here, it is I1 into 8I1 plus I2 into 53 plus J75, which is equal to 0. So this is equation number 2. Then here again just solve by solving 1 and 2, by solving 1 and 2. Then here we will get by solving 1 and 2, what we can do 1 and 2. Then you will get the values of I1 and I2. So here I1 value here it is 0.89 at an angle of minus 54.43 amperes, and I2 value here it is 0.078 at an angle of minus 109.18 degrees amperes. So this is how we can find the values of I1 and I2. As you can see here, in the first case, when the directions that we are considered as it is given in the problem, so I1 is 1.03 at an angle of minus 45, but here I1 is 0.89. So that's what, because based on this dot convention also the values will change. So that's why when we are solving the problem, it is very important to concentrate on these signs, right? So these are the various numerical problems based on the dot convention principle, right? So in the next class we will discuss the next topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.